Hi, welcome to my video on the rational root or zero theorem. The p of x equals ax to the n, bx to the n minus 1, cx to the n minus 2, etc. down as far as k. A, b, c, k are integers, and n belongs to the whole numbers. That's the exponents, because the exponents can't be negative or fractions. Let p be the integral factor of k. Let p be the integral factors of this constant term on the end. And q be the integral factors of a. A is the leading coefficient. And notice the integral factors. They are the integer factors. Integral factors are integers. Integral factors are integers. Note a, coefficient of the leading term, and k is the constant term that's on the end. So a rational factor are p divided by q. So the factors of k are divided by the factors of a. So p and q. The rational factors p over q are the possible rational zeros or the roots of an equation that we have equal to 0. So we make the equation right here equal to 0, which I left out. Then k is a negative 4, a is 3, k is the constant, 3 is the leading term. So p is the factors of k. So that's plus minus. Factors of 4 are 1, 2, and 4. Q plus minus are the factors of a. So it's 1 and 3. So the p is plus minus the 1, 2, and 4. Q is plus minus 1 and 3. So I haven't written, notice I left the plus minus outside without writing them down on each of these. So therefore the answer is plus minus, and here's how I do it. I take the 1 and I divide into each of these. So it's 1, 2, and 4. Now I take the 3 and divide into each of these. So that gives me 1 divided by 3, 1/3. 2 divided by 3, 2/3. And 4 divided by 3 is 4/3. So these are all the possible factors as rationals. Notice rationals are fractions. A rational can also be an integer. So the integers are not fractions, but the fractions can be integers. So as you know, like 4 over 2 is a 2. 4 over 2 is a fraction, but it reduces to 2. Let's continue. Now we have this cubic, 3, 2, 1, 0. So k is 9 and a is 2. So the factors of p are, let's go with the plus minus, is 1, 3, and 9. The factors of q are of 2, 1, and 2. So the factors of p are plus minus the 1, 3, and the 9. The factors of q are 1 and 2. So when we do the p divided by the q, this is the p on top, this is the q on the bottom, we will get plus minus, and here we go. So 1 divided into each of these will give me 1, 3, and 9. Now we take each of these and divide by 2. So we get 1/2, 3 over 2, 9 over 2. 1/2, 3 over 2, 9 over 2. So all the factors of q are divided into each factor of p. And there they are, all the possibilities. And here we have notice we have one term missing, but that doesn't make any difference. The leading k is the 8, the constant term. A is the 4, the leading term. So the factors of p p are plus minus. The factors of k, which is 1, 2, 4, and 8. The factors of a, which is 4, is 1, 2, and 4. So the factors of p divided by the factors of q, so the factors of p divided by the factors of q are plus minus. Factors of p are 1, 2, 4, and 8 divided by the factors of q, which is 1, 2, and 4. And if you work out that, let's see what we have. So divide by 1, 1, 2, 4, 8. Now let's divide by 2. So 1 divided by 2 is a half. 2 divided by 2 is 1, already there. 4 divided by 2 is 2, already there. 8 divided by 2 is 4, already there. Now let's divide by 4. 1 divided by 4 is a quarter. 2 divided by 4 is a half, already there. 4 divided by 4 is 1, already there. 8 divided by 4 is 2, already there. So these are all the possible factors that what we call rational factors. Notice again, you have integers and fractions, but rational means as of a fraction. So the difference between the rational factors and the integral factors, integrals are integers. Okay, let's continue. Notice I have an equation on top of here. So if I take this equation and solve it, x is 3 over 2. Why I'm showing you this, notice it's the 3 divided by the 2. When you go to solve it, the 3 moves over and you divide by 2. So this is similar to, that's the p and that's the q. So it's this one and the n divided by the leading one. And if you think about it, all the factors of, let's look at it, all the factors of 3 are 1 and 3. All the factors of 2 are 1 and 2. So the possible answers, even though this is an easy one to do, the possible roots, plus minus, are, divide by 1, I get a 1 and a 3. Divide by 2, I get a half, and I get 3 over 2. So notice the answer is 3 over 2, plus minus. So there it is there, the positive one. So that's the answer. But I wanted to show you that it's 3 divided by 2, PQ. And over here, I have a trinomial, which is a quadratic. So there's 2 factors. So the way we do this, we say the product is A times C. So A, B, and C. So the product is A, which is 15, times C, which is 2. So the product is 30. So the product is 30, so it's 1 times 30, 2 times 15, 3 times 10, and 5 times 6. And the product is A times C, and the sum is the B. So the sum is B, so B is 11. So the sum is 11. So what terms here will multiply to give you a 30 and add to give you 11? So it's, no, that's 31, 17, 13, so it's 5 and 6. So what we do, we take the 5 and the 6 and put an x with it. So 5, 5x, and 6x makes up the 11x. So the 11x is changed to 5x and 6x. Now we have 4 terms, so we take the 5x out by factoring. We get 3x plus 1. We take the plus 2 out, and we get 3x plus 1. So 3x plus 1 is the binomial that's common. So when you take that out, you got a 5x left. When you take it over here, you got a plus 2 that's left. And so now we have the two factors. 3x plus 1 equals 0. 5x plus 2 equals 0. So 3x equals negative 1. X is negative 1 over 3. 5x equals negative 2. X is, divide, negative 2 over 5. So notice the two factors. But what I wanted to show you again is the 1 divided by the 3, PQ. PQ. But if you look up here, the factors of P are plus minus. Factors of P are plus minus 1 and 2. The factors of Q are plus minus the factors of 15. 1, 3, 5, 15. So the possible factors of P over Q is, now do the revision, 1 divided into 1 and 2 gives you plus minus 1 and 2. Divide by 3, you get 1/3, 2/3. Divide by 5, you get 1/5, 2/5. Divide by 15, you get 1 over 15 and 2 over 15. So these are all the possible factors. So you notice these are all plus minus, but we have a 1/3, which is right there. Plus or minus is negative. And we have 2/5, which is right there. So I wanted to show you that how we solve this with quadratics earlier on, we took it for granted that we did the 1 divided by the 3 and the 2 divided by the 5. So I'm trying to illustrate that it's the factors of 2 divided by the factors of 15, thinking about it that way. Now, the rational zero or roots theorem, if the h of x is equal to this expression that we named for, where a, b, and c, and k belong to the integers, and n is w, let p be the factors of k, let q be the factors of a, then p over q is a 0 of the h of x, which is the same as the p of x or the v of x, if the h of p over q equals 0. Remember before we had the p of x equals 0. So if we had the p of a equals 0, that means that the remainder, you got 0. So the p of a was the remainder of 0. So when a number makes the 0 remainder, then that's what this is saying. So when you do the h of p over q and get a 0, that's the same as having a 0 remainder. But they're fractions now, as well as integers, as well. Okay, let's continue. Is a half a 0 of the p of x? Now, I can do it two ways. I can take the p of a half and sub it in. So I'll do it right now two ways. So I sub the half in, and 1/2 squared, 1 times 1 is 1, 2 times 2 is 4, plus a half minus 2. Multiply, and that's a 2, and that's a 3, so that's 3 over 2 plus a half minus 2. So 3 over 2 is 4 over 2 minus 2. 2 minus 2 is 0. So that means 1/2 is 0 of this expression, which is the same as saying if this was equal to 0, then 1/2 would have been a root. So we got a 0 of a polynomial, or we get a root of an equation equal to 0. But if you took the half and did synthetic division on 6, 1, negative 2, that's in descending order, nothing is missing. Bring down your 6. Half of 6 is 3. 1 plus 3 is 4. Half of 4 is 2. And we have 0 remainder. So that's a 0 remainder. So that means a half is a 0 of the polynomial. If we do it this way, by subbing it in, we get a 0 remainder, because the p of a half, if we get 0, then that means it's a 0 of the polynomial, or a root of the equation. So you got two choices. Synthetic division is a fast way to do it. Okay. Is 2/3 a root of this equation? That's on the top. 3x cubed plus 8x squared minus 20x minus 16 equals 0. Now notice this equation is equal to 0, so therefore this is a root. So if it's a root, I'm going to do synthetic division. Is it a root? So let's do 3, 2, 1, 0. They're all there. 3, 8, negative 20, negative 16. I'm doing synthetic division. So we bring down to 3. So negative 2/3 times 3. The 3's cancel, and I get a negative 2. Add 6. Negative 2/3 times 6. 3 and 6 goes 2. Negative 4. Add negative 24. 3 and 24 goes 8. 2 8s are 16. Negative times the negative positive. 0 is the remainder. So that means 2/3 is a root. Notice 0 is the remainder. Is a negative a half a 0? So notice it's a root of an equation equal to 0. If you have the f of x, p of x, then it's 0 of the polynomial. So let's take the negative a half and do synthetic division. 4, 3, 2, 1, 0. So we got a 6, 1, negative 7, negative 1, 2. 6, 1, just make sure I got it written down right. And we're going to do the synthetic division on it. Bring down to 6. Half of 6 is 3, so it's negative. Add, you get negative 2. Negative a half times a negative 2 is a positive 1. Add, we get a negative 6. Multiply, half of 6 is 3 and it's positive. Add, we get a 2. Half of 2 is 1 and it's negative 1. Add, we get a 1. Notice the remainder is 1. The remainder is 1, so a half is not a root. Oh, I said root, not a 0. So repeat, you get a 0 of a polynomial, f of x, p of x, h of x. You get a root of an equation equal to 0. So because the remainder is not 0, negative a half, negative a half is not a 0. Okay, another type of problem. If a half and negative 3 are roots of this equation, notice we got equal to 0, so we have roots. Find the other ones. So that means if I'm going to do, I could sub it in. If I sub a half into here, then it's going to be true. 1/2 subbed into place of x is going to make it equal to 0. So that's only telling me that it's a root. But sub a negative 3 into here, and it'll give me a 0. But if you do synthetic division with the half, then what we get, it's just want to make sure, 4, 3, 2, 1, they're all there. So I got a 2, I got a 3, I got a negative 12, I got a negative 7, and a 6. If they're roots, that means, right here you're going to have a 0 remainder. So what happens? Doing synthetic division, I get a depressed equation. And I work on that depressed equation, that'll become a quadratic. So we start with x to the 4. We'll put the two of these in with synthetic division. That means when I'm finished, I'll end up with a quadratic that I'm going to solve. So here we go. Put a 2. Half of 2 is 1. Add 4. Half of 4 is 2. Add negative 10. Half of negative 10 is negative 5. Add, and I get a negative 12. Half of negative 12 is negative 6. And I get a 0 remainder. So we knew a half is a root, so we knew we were hopefully going to get a 0 remainder. Now we take the depressed equation. Instead of writing it down as this is x to the 4th, so this is x cubed, x squared, x and a constant. So instead of writing down x cubed, x squared, and like that, I'm just going to write down the coefficients. Now I'm going to divide by -3. When I divide by -3, I'm going to get a 0 remainder, hopefully, if I do it right. Bring down to 2, multiply, -6, add, -2. Multiply, I get 6, -4. Add, multiply, -3 times -4 is 12. Add, I get a 0. Okay, so half is a root, that's 0. -3 is a root, but I got a depressed equation. Notice this equation now is 2. This was x to the 4th. This is x cubed. This was x cubed. Dividing, we get an x squared. So that's a 2x squared minus 2x minus 4 equals 0. Notice 2 is a common factor. Take the 2 out. So we get x squared minus x minus 2. And so this is, let's see, hopefully it's factorable. I got to use the quadratic formula. X squared is x and x. Factors of 2 are 2 and 1. Because the product is -2 and the sum is -1, so I got a -2 and a +1. Multiply. -2 times 1, -2. Add, -1. So we have x minus 2 is equal to 0, or x plus 1 is equal to 0. X is equal to 2, x is equal to -1. Notice we can't say 2 is a constant. So if you want, you could have divided by 2 and got x minus 2 times x plus 1 equals 0. So if you divide by 2, then 2 cancels out. 2 into 0 goes 0. So you can leave the 2 there and just work on these two factors. You don't say 2 equals 0 because that's impossible. So if you divide by 2, like that, you get x minus 2, x plus 1. 0 divided by 2 is 0. So you leave the 2 alone, divide by 2 to get this, and then work it through. So notice now we have the other two roots of 2 and -1. Notice there's 4 roots altogether. There's 2 of them. And working with synthetic division, you get a depressed equation. But you can only call this a depressed equation here, which is 1 degree lower than what this is, if you have a 0 remainder. Okay. And let's continue. One more before we finish. 3/4 is a root of this equation. X cubed, x squared, x constant. Express the polynomial in factored form. So again, I will do synthetic division because it'll give me a depressed equation. So I have a 4, 3, 2 is all in order. 4, 19, 24, and 12. Draw a line. Remember, that's a root, so I should get a 0 here if I do it right. Put down a 4, multiply. 4 into 4 goes once, -3. Add. That's 16. 4 into 4 goes 4 times, -12. And that gives me a 12. 4 into 12 goes 3. 3 times -3 is a -9. And we have, did we do something wrong here? 3/4. 4, 3, 16, and -12. Should have, let's see, bring down a 4, -3, -16 is a, unless I can't multiply correctly, 4 is -12, 12, and 3 is -9, there's a 3. So -3/4 is not correct. -3/4 is not a root. Cannot express it in this factored form because we didn't get a 0 remainder. So it was an error made on my part. I should have had another number right here, so this would have worked out. So if I had a 9, watch this, I made an error. If I had a 9 and a 9 right here, that would be a 0. So I would have 4x squared plus 16x plus 12 equals 0. Again, sorry about that. I thought I checked it out, but obviously I didn't check it out. So 16, that's 4, yes, right? Just made that little error. And anyway, I'm going to put a 9 here, so I get a 9 on the end with a negative to get a 0 remainder. So we take a 4 out, we get x squared plus 4x plus 3 equals 0. And that's factorable, or I got to use the quadratic formula. X factors of 3 are 3 and 1. Product is positive, sum is positive, so it's 2 pluses. So that means that x plus 1 is equal to 0, or x minus plus 3 is equal to 0. X is equal to negative 1, x is equal to negative 3. So, barring that error that I made there, little slip, sometimes when you check things, you think you've got to check right, but I'm the only one proofreading it. So again, I do make errors. So that's a 9, that gives me a 0. This is the depressed equation, factored it. So the other two roots are these. Now, I wanted in factored form, so I really didn't need. So watch what happens. If this is a root, this is x minus plus 3/4, because the factor is the opposite of the root. And I have a 4 and an x plus 1 and an x plus 3. So there, that's the factored form. Did I want to find the roots? Yes, I could find the roots. Put the root back in and I get plus 1. Put the root back in and I get a plus 4. Put the 4 here, because that's all the factorization. Now, notice what happens. When you take the 4 and multiply by this binomial, 4 times x is 4x. 4 times 3/4 is plus 3. So it becomes this trinomial, which is made up of these three factors. So notice that we had x, x is equal to 3/4. That's a root. X is 3/4 is a root. Put it over 1, cross multiply. 4x equals negative 3. 4x plus 3 equals 0. So this 4x plus 3 is right there. And there's the other two, x plus 1 and x plus 3. But if you do it this way and write down the roots in here with the 4 there, the 4 changes this fraction to an integer. So 4 times x, 4x, 4 times 3/4 is 3. So there's the factored form that has this 3/4 root is right here. The negative 1 is here and the negative 3 is here. So this is the polynomial in factored form. So I could have gotten the roots, yes, and then subbed them in, but I needed the 4 in order to eliminate the 4 that's in this fraction. Or I could have changed each of these. See, that's an x plus 1, that's an x plus 3, and this is 4x plus 3. So put the 3 of them together and you get the equation in factored form that represents this polynomial here, cubic polynomial of 4 terms. So sorry for that little mistake there with the 9. And so that we've used what we call the rational theorem. And rational means fractions. So you could have integers and fractions right now, because it's the factors of p divided by the factors of q. And if you like my video, click the like button, click the subscribe button. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content of my YouTube channel called Math Fully Explained. Thank you for viewing my video. Bye-bye.